with some links, and we're told to upload week 1 to week 4 experiment videos there.
Okay.
Uh, yeah, but I could not upload a week 3 experiment video as I don't have that particular IC. I could not
Oh,
even manage to find it in nearby stores, and
so
it's on the way currently,
okay. So in how
but
many
didn't.
days it will be received by you?
No, ma'am, I haven't
Approximately?
yet received it.
Okay, okay. So maybe in few days you will receive it and you can just upload it. Like you can inform the concerned authorities, the coordinators about that you have not received it yet and you will take some time to upload the videos. That will be sorted. Okay.
Yes, ma'am, that's the concern. As the deadline is 18th of this
Again.
month, and if I
Okay.
get the delivery too close, even if 1 or 2 days earlier, I could not manage to upload it because I need some time to perform
Yeah,
experiments.
yeah, sure. That I think will be taken care of if you like you did not receive the components, so that will be taken care of. Just send us an email and we just cooperate in that. No problem. But do not
I send
extend.
email to whom Victoria, ma'am, or the
Okay,
support is.
okay. So she would have taken care of it. So don't worry.
Okay, ma'am.
Another thing, I think for this experiment, you guys have conducted the experiment or have at least a few understanding of the experiment, right? Today we'll be having half-wave, I think half-wave rectification, right? With diode and understanding the diode characteristics.
Yes, ma'am.
So, let's, so we'll discuss today about discuss and solve the doubts regarding the diode characteristics and half-wave rectification experiment. So, do you have any problems with the or any doubt regarding the experiment?
I have some doubt in part two, the setup part. Actually, I have some confusion in what is being told to do. As we are told to introduce a 2.5 volt load resistor on the lower side of the combination and uh, input a sine wave of 50
Ah,
hertz frequency.
yes,
So actually, ma'am, in order to capture the property of the working of a half wave rectifier,
yes,
we need to provide it a pure sine wave, which is positive for some period and negative for some period. So that's
yes,
why we are achieving it by this method, as a
ah,
DLM kit will not provide any negative part signal.
yes, correct, yes.
Okay. Um,
That is the only reason. So, what is the doubt?
Uh, Let me see. I had some. Yes, ma'am. The dot is in the experiment part. We are told to observe and record the actual waveform of the output signal for the full amplitude input. So, ma'am, as you know, we can't even provide a full sine wave input to the board. That's why we are considering 2.5 volt offset at lower end. But how can we measure the actual waveform? We can also measure either in negative.
No. Actually, it's like after you give the offset, after you provide the VDC, right? That is the actual. It will be varying from 5 to 0, right?
Yes, ma'am.
So 5 and 0, the maximum output will be maximum amplitude, positive amplitude will be 5, and the minimum will be 0, right? And it will be varying across an offset of 2.5, right?
Oh, I got it. So the mean position will be at
At
voltage
2.5.
2.5.
Yes, yes,
Okay,
yes.
okay. Yeah, yeah.
That is what like it is being applied, right? 2. It will just shift the like input voltage Vs to 2.5.
Okay,
Understood,
ma'am, I
right?
got it.
Ah.
Yes, ma'am.
No. Any more now?
Ma'am, your voice is cracking too much.
Change the headphone, everything, but why is it cracking? I don't know. Maybe I'll rejoin again and just check one more time. Okay, just give me
Yes, ma'am, it will be
10
fine.
minutes.
Yes.
Hello. Hello, everyone. My voice is fine now. Hello, my voice is
It's
fine
bet
now.
it's better.
So, any more doubt you have? So, shall I give a brief of the experiment that you have to do?
What, ma'am?
Shall I give a brief of the experiment that you have to do? So, if anyone has any doubt, you can ask later on. I'll give a brief of the experiment that you will have to do. So, I don't know. I've checked already my like connections and everything, but it's still, if it is still my voice is not clear, are you able to like follow through what I'm speaking?
Yeah, but it's sometimes difficult when your voice starts cracking or losing signals. Ma'am, are you able to hear me clearly, or is my
Yes,
voice
I'm
also?
able. Yes, yes. Your voice is clear to me, but my voice is not clear. That is what I'm concerned about. So,
Right now, it's better. We can hear you, but sometimes it's problematic. It's
okay,
fine currently.
okay, fine. So I'll give a brief of the experiment. I'll share my screen with you, so with the people, and you can just follow through.
Yes, ma'am. It will be good.
So my screen is visible to you, right?
Yes, ma'am. It's visible.
So this is a second experiment in the analog domain, and we'll just understand this experiment is mainly to understand the diode characteristics, the IV characteristics when the diode is forward biased, how this input voltage and now input with input voltage, how the current through the diode will change, and you will understand that there will be some fixed cutoff voltage, and after that the fixed forward voltage, and after that the diode will conduct. So that all behavior of the diodes will come to know from this experiment, and what will happen in real life when you work with some practical diodes, that will understand from this experiment, and how you can use PN diode, PN junction diode, to work as a half wave rectifier. That also you will able to understand and maybe try to look at in depth. So that is the aim of this experiment. And so the components will have one normal diode and one Zener diode. So as you can see, we'll just go through the last part. There is one experiment regarding with Zener diode as well. So you have to do the experiment. So repeat part 1 with, in the part 4 it is already written. Repeat part 1 with the Zener diode. Replace the diode with the Zener diode. Then you have to do the experiment, what it is told in the part 4. So mind you, you have to do all the parts. So each part will carry individual marks. So you should attempt all the parts. Otherwise, your marks will be deducted for those different parts, even the parts that you have not attempted. So this is one point. And you will also have one LED with you in the kit that will be provided from the institute. So you will do the repeat part 2. You have to repeat part 2 with LED provided to you. In that, you will if you set the frequency of the signal voltage that is the input signal to 1 hertz, you will be able to see the flickering of the light. So that will give an idea, okay, how the frequency play a good role in in the working of the circuit, and you can actually see that what happens if you work in a lower frequency. So that, to give you a feel of that, that's it. But you have to attempt this question and repeat part 2. Okay, using a LED, which is which works like a normal diode as well. So I will explain first the part 1 that will give you an overview of the diode IV characteristic study. So first of all, if you refer figure 1, please refer figure 1 in your laptop, in your whatever you are referring to right now in your PDF. So you have to connect a diode and a resistor of 1 kilo ohm. 1 kilo ohm, I think it will be already given in your kit. And in series as shown in figure 1 kilo ohm, like this. Apply a DC voltage across the diode resistor combination using the analog board. So you will apply some DC voltage, maybe 5 volt, and then in the next part, gradually increase the input voltage like DC volt. So you can maximum you can keep it at 5 volt, and minimum you start from 0 volts. So until the diode starts conducting. Now consecutively, when you change the voltages, you will also check the current values. So monitor the current flowing through the diode by measuring the voltage across the resistor. So why RS is given? Because to understand the current. So if the diode and the RS all are in series condition. So to understand, to get a quantity of how much current is flowing through the circuit, we connected an RS, and otherwise we just could connect a diode, right? So we connected an RS. It's a passive component. So you can measure the voltage across AB, and that voltage, that is VAB divided by RS value, will give you the current flowing through the whole circuit. So that in that way you will get an idea of how much current is flowing in the circuit when you increase the signal voltage. So that is the feel of it. Now cross RF using a multimeter. So monitor the current flowing through the diode by measuring the voltage across the RS using a multimeter. Now increase the voltage slowly until a current of at least 1 milliamps passes through the diode. So record the corresponding voltage and the current values. So until the 1 milliamps current, you have to after the cutoff voltage at forward breaking voltage, that is 0.7 for the diode. So there will be some current starts. Then only the current will start flowing, right? Before that, no current will flow. So you have to measure the voltages at where the current through the circuit is 1 milliamps and record the voltages and the current values. Now, what you have done is you have increased the voltages, that is signal voltage, from 0 to 5 volt, and accordingly you have also noted down what are the current values in steps of 0 0.5, 0 0.2, whatever the step size you want to keep it. Then what you have to do is flip the diode, that is, you will reverse bias the diode. Now vary VS1, again you increase the voltage VS1 and note any negligible reverse saturation current that may be present. So you will increase the VS and you will see that you will find whether there is any very negligible reverse saturation current in the domain of some milliamps or very 0 point something milliamps saturation current is flowing through the circuit or not. So that will give you that the IV curve of the diode using the recorded data. So whatever data you have collected so far, that will give you the IV curve of the diode using the recorded data. So you have to plot the IV curve for the diode both in forward and reverse bias regions of the diode. So you have to show that curve. Otherwise, we will not be able to give you any marks in that. So that is the end of part 1. Now, as you have completed looking at that the diode characteristic, now what we'll do, we'll use that diode to to rectify a sinusoidal signal. So how to do that? First of all, we'll do the connections given in figure 2. Now, construct a half-wave rectifier circuit as illustrated in figure 2. Use a diode for rectification and connect a load resistance of 10K across the output terminals. That is here 10K across the output terminals. Now, the analog board can be used to generate a signal Vs using with a DC value of 2.5. As I have already mentioned to Nilesh, I think I was discussing with Nilesh regarding the mean value of like he said that mean value will be 2.5. It is already mentioned here that to generate a signal Vs with a DC value of 2.5 and an AC voltage at a frequency of 50 hertz. So at a frequency of 50 hertz, so the maximum will be 5 volts you can give and the minimum will be 0. So, and with a DC value of 2.5. So 2.5 will be the amplitude of the AC signal. So introduce this signal to the rectifier using either a hyper circuit or by lifting the lower side of the load resistor to 2.5. So this is what he here it is mentioned. So we can use 2.5 to lift the circuit, lift the voltage. So we'll give 2.5 sine omega t. Sine omega means omega will be 2 pi f. F is 50. And 2.5 will be the DC that will lift this thing. Now experimenting. So gradually increase the amplitude of the input signal in steps until the maximum is reached. For each step, so you will gradually increase the input, like before it will be 0, then you will increase the amplitude of the input signal in steps until the maximum is reached. For each step, note the DC voltage across the load resistor using a multimeter. Same as said in figure in part 1, you have to note the voltage across the AB, that is across the 10 kilo ohm resistor. Observe and record the actual waveform of the signal, output signal for the full amplitude input. Now repeat step 3 after introduce. Now in the step 4, after you will have an you will like plot the current and the voltage values for gradually increase the amplitude of the input signal. For you will increase the input signal and gradually measure the DC voltage across the load resistor using a multimeter. Now what you
Ma'am,
do?
I have a doubt here.
Yeah.
Can I ask?
Yes.
How can we measure DC voltage if we are providing AC signal there or even varying signal?
See,
It
there
will
is
be average.
RMS, right?
Okay. So we are doing so to measure the RMS voltage.
RMS or average? Average, I think for AC voltage is 0, right?
Excuse me,
Yeah,
ma'am.
So you will be
for
measuring.
AC is zero.
Yeah,
We need to
correct.
measure RMS. Yes.
Correct. So, so in the fourth step, you will do after so you will introduce a capacitor using the largest capacitor that is available in the box. Now you will see that how the before some signal is there. Now you will attach the capacitor and see how the signal changes, how better you get, and what are the changes you get that you have to that you will find out. I will not say right now. You do the experiment, find out after using the capacitor across RL what you will get, and you have to give a good explanation of what are the changes you're getting. So analyze the rectified output waveform and compare it with the input waveform. Compare the average output voltage measured with the expected output from calculation. List the reason of for the deviation, if any. Now calculate the rectification efficiency and ripple factor of the rectifier circuit. That is a bonus point that you can just for your own knowledge, you can just study these points. What is rectification efficiency? What is ripple factor of the what is ripple factor? What is the significance of it? And then you will find out. You can always find the values of the half-wave rectifier. So every half-wave rectifier has rectification efficiency and the ripple factor that will tell you the quality of the rectification. So those values you can find it out for your own knowledge. So that is the end of part 2. Now part 3, you will refer this part as figure 2 only and check like how the LED behaves when you give the signal at 1 hertz frequency. Now, for part 1, for part 4, you have to use refer figure 1, and that will give, and you have to find both the reverse bias region and the forward bias region as set here. No? This region. So plot the IV curve of the diode using the recorded data, analyze the forward and reverse bias regions of the diode. So that for Zener diode also you have to find out and see the difference that what happens in the reverse saturation region, because Zener diode is most related to the reverse bias region, right? So find it out and give an analysis and also explanation that will help you to get score more marks. You just have to make some changes. 1 kilo ohm resistor to be replaced with the 200 ohm. That you have to find, and then gives the explanation of what are the changes in the IV curve as compared to the normal diode for Zener diode. So that ends your experiment 3. Okay.
Ma'am, in part 3, we just have to observe the effect as how a LED behave, or we also have to plot something.
No, in part 3, I don't think you have to plot something.
Okay, ma'am.
Just a second.
Actually, ma'am, I have a doubt.
Yes.
Hello.
Yes.
Yes, ma'am. Actually, it is about submitting the previous assignments of the work for the electronics lab. We received a mail regarding we need to resubmit all the documents. For week 2, I have done I have a zip for I have some PDF to share with you. That is, I have made some calculation that those things I need to share. I feel like, and is it okay if I share a zip file?
Sorry, I did not understand your doubt.
Yeah,
Sorry.
sorry, ma'am.
Yeah.
Actually, because beyond video, I have some materials to be to show to submit in the assignment. Like I have
Okay.
done some calculations, and I would just want to share those calculation in the assignment.
So can't you just take a screenshot of those calculations and put it in the video?
Screenshots, ma'am.
Just like take a photo of those of those calculations, whatever you have done, So
Sure.
while in the you include those photos, pictures
Sure.
at the back of the videos, saying that
Yeah.
these are the theoretical calculations you can refer to. And while checking your assignment, I'll just have a look in the calculations.
Sure.
That
Sure.
will be even better, because so that there will be no mixing of your data
Yeah.
with somebody else, right?
Okay.
So
Yeah.
that will be
Sure.
good. Yeah. So
Yeah.
any more doubts you have regarding this?
Nothing.
Okay. So anyone have any doubts regarding this experiment?
I tried to do the experiment. The first part, when I supplied 0.7 volts,
Yes.
I was not able to get a proper current value. That is, it was always fluctuating. It wasn't staying at a particular value. The current value is not.
So have you increased the voltage value?
Yes. So
yeah, there is one
smaller
point.
values it is constant, but
for what values it is constant?
For 0.5, 0.6, for these values I am getting constant current. Just a little bit greater than that, I'm getting it's always fluctuating. It is not staying the same.
Oh, okay.
When I measure too much
In the analog this thing, no, what app you are using, the Pixel Pulse app,
Yes.
right? So there will be some options. Wait, you have opened the Pixel Pulse software?
Yes.
Just a second, I'll also open. There is one option. I think.
Ma'am, if we turn repeated sweep off, it goes away.
Yeah, correct. If you turn repeated, I was about to say that. If you go to the settings, no, there is this one
Your
settings.
screen is not visible.
No, I'm not sharing my screen, that's why. But I'll just tell you that if you go to the settings, shall I share it? Just a minute. Yeah. So I have not connected my analog discovery kit, ADLM, sorry, ADLM kit now. So that's why it is blank. Are you able to see my screen?
Yes, ma'am.
So if you go here, there's some repeated swing. Okay. Try. I'm not. I think you have to disable this repeated swing. Okay.
Okay.
So just check whether it is enabled or disabled. Just try doing both the combinations. Okay. I think that is the problem.
Okay.
I think so. Okay. So if it is enabled, you can disable it, or if it is disabled, you can enable it and find out which one works for you. Okay. I'm not. I'm a little confused about it, but this may be one of the issue. Okay.
Okay.
Any more doubts you have?
There is no need to have the Zener diode in a reverse bias.
Yeah, you have to do, because the Zener diode main working is in the reverse bias, no?
Yeah, but in the components list, I could see that the breakdown voltage of the Zener diode is 3.6 volt.
Yes.
But when we conduct this experiment, we supply a maximum voltage of 5 volt, and we connect the other terminal in a 2.5 volt, and the voltage difference there will be 2.5 volt, right, ma'am? And we don't get to see any breakdown voltage, right?
Maybe you can increase the voltages.
No, but the maximum voltage is 5 volt.
Wait, just a second. So you are doing the Zener diode breakdown voltage is 3.6, right?
Yeah.
So beyond 3.6, only the breakdown voltage will happen, right?
Yeah.
Breakdown will happen, right? So your question is, you are not able to, but you are giving this 0 to 5.
Can you just share the PDF, ma'am? It could be very much useful.
Just a second. Here, no. You are giving this DC voltage from 0 to 5, right?
Yeah, yes, ma'am.
So 3.6 is less than 5, no?
Yeah, it is. Yes, ma'am.
So it should show a breakdown voltage, right?
Yes, ma'am. It
So
is about the breakdown voltage.
So it is not showing?
No, I'm just asking that we attach the 2.5 volt in the other end, right? for a half-wave rectifier?
No. Oh, Zener diode you will do for only part 1. See?
Okay, yeah.
Correct?
Okay, ma'am, I got it.
Then I think you will get, because in the
Yeah.
part 1 you will only give DC voltage,
Yes,
right?
ma'am.
And
Yes.
so you will get it, I think.
Sure.
But for normal diode you will not get it. It will be far more, right? So
Yeah.
that itself you need to show that okay, this is the thing with the Zener diode. Okay.
Okay. Yeah.
That is the aim of the doing this
Okay,
experiment.
ma'am. Yeah.
Okay.
Yeah. Sure.
So any more doubt you have, anybody?
Ma'am, if we want to measure a voltage at any node using the DLM kit, we can do it by measuring it in channel A or channel B. But
Yes.
suppose by default it will only measure with reference to the common ground pin. So suppose we want to measure between two nodes, node 1 and node 2, and said that both of those nodes, none of them are common or ground pin. So can we do that with the DLM kit?
I don't think so. I
Because I faced such issues in
yeah.
the week 2, and I also attached some references stating the problem in the videos.
Yes. I think it is not possible. Okay, because you have to if you are without grounding it, so reference as a ground, so there will be this problem. This you have to take the data simultaneously, right?
Yes, ma'am. I was
So
thinking so because I was reading very inaccurate values when I measure something through multimeter and same thing through the kit because calibration
there,
issue.
yeah, correct. There will be error, more error. Okay,
Yes.
and the output will be error. Yes, that also you can find it out. Why? That will give you a good understanding of what happens, why it is not possible. Actually.
And ma'am, regarding voltage measurement in part 2, where we are set to measure the DC voltage across the load resistor using a multimeter, actually will not it swing much if the voltage is fluctuating, or you think it will settle down to a voltage?
RMS value will be constant, no? Same, no? If it is RMS is
Uh,
the amplitude divided by root 2, right?
Yeah, I think so. It goes like that. But if we get any difficulty in measuring through a multimeter, can we do that measurement through
Using through ADLM?
ADLM? Yeah, and then
Yes.
calculating the
Yes,
yes.
yeah. So you can always do measurement through ADLM. You can actually this is a good idea. If you like, you can do the measurement with ADLM as well as multimeter. So that will give you understanding if, whether the same values are you getting or not. That will confirm your output also. Okay, got
Yes.
my point, right? So if you check with ADLM and multimeter both, you can check and you will get an understand like if there is any fluctuation between the two outputs or not. Okay, whether you are getting the correct value or not. Okay. So ADLM, I think there is some RMS value it will automatically say. I think no. Measure
Yeah,
the voltage.
it is difficult because RMS only we can measure when it is in repeated sweep mode, and the time we turn the repeated sweep mode on, the multimeter goes crazy. It just keeps swinging.
No, it's not. Don't do simultaneously. You can do one by one, right?
Yeah.
Measure it in multimeter and then enable that and just check in this thing.
And ma'am, I
Huh.
wanted to ask one more thing that when we try to make measurements, plot something through the DLM kit, suppose we measure the whole range of input and output response at some time, and when I come back and do the same experiment, I get very different values. I mean, why is it like that?
But it should not be like this, right?
Yes, ma'am. That's my concern. Is it?
So you are saying that you are getting some voltage value now. If you give, let's say, for example, this figure one, you are giving 0 volt. You are getting some current values here across, like current here, right? You are giving 1 volt. You are getting some current value flowing through this circuit.
Not
Could be constant.
exactly. For the current, I faced issue in the experiment of the digital experiment. There, I connected a NAND gate with one input being high, so it behaved like an inverter. And I measured the input-output characteristics, the voltage transfer characteristics there. So I measured all the way from 5 volts to near 0 volts. And when I measured the same thing again from 0 volts to 5 volts, or even from 5 volts to zero, the period where it rapidly shows the transition phase, it highly, I mean,
Is it
goes,
a digital question or an analog question?
yeah. But it happens also in some analog
happen.
domain.
But in analog part here, if analog part, I'm not saying like there should be repeatability.
Uh,
So
and regarding because of that, ma'am, we are limited to certain accuracy beyond which we can't measure. So if we are said to measure very accurate data and increasing the voltage by very small step, it may not be meaningful. So
that's why
what
there is
should be
some.
the step?
You are saying that accuracy. You want to check the accuracy of the circuit.
What, ma'am?
You want to check the accuracy of the circuit.
I'm not getting you.
So I'm also not getting you what you are wanted. What is your doubt is all about. That's why I am asking you.
I,
So what I'm saying is that
I,
if the
I,
circuit is not repeatable, then your circuit is not correct.
yeah. Okay. It
In
was
any domain.
some. Yes. But
So
it
if
was not very great, very large fluctuation, but significant one.
very
Anyway, in
if it is
analog,
if it is very small changes, that will if any circuit we do repeatability test, we will check multiple times. We'll take the outputs at different time instance, and we will say that this is. There will be obviously there will be some variations because of the circuit elements are big because of anything like temperature variation, humidity variation, whatever things. So that will induce some changes in the output. So whatever in future, if you do any analog experiment, you will come across these fluctuations, but it should not be very high. But those fluctuations are always we refer them, or we say that let's say 2 volt plus minus something, or we will tell them in case of by specifying their accuracy and standard deviation. So those things will come later on. As for this experiment, I don't think you will get some different values. If you very less fluctuations will be available in the output. Am I
what
able
should be
to?
the step size, ma'am, that you will consider?
What? I didn't get you.
What should be the step size that will be considered
You can do
as
from
good?
0 to 5 volt. You can take every 0.5 volts or every 0.2 volts like that. Step
Yeah,
size,
then it
right?
will be fine.
Yeah, I
Yeah,
think
then
so.
it will be fine.
Fine, better.
Yeah.
Because if you take 1 volt and 1 volt, then only five values you'll get. So that will not define the curve, right? So better as
No, I
many.
was trying to take a step size of 0.05. That's why I was getting frustrated due to the accuracy.
Better you take it 0.2. That will get in every 1 volt, you will get five values. So that will give you. I think that is enough.
Yes, ma'am, fine.
So any more doubt you have? So
No.
will yes.
Ma'am, I had doubt in part one. Hello.
Yes.
Ma'am, I'm talking about the step two. That is, I mean, we have to measure the voltage drop across the resistor of 1 kilo ohm, right?
Yes.
So, ma'am, instead of measuring the voltage drop across that resistor, if what if we directly connect the ammeter in series with that diode and resistor, and we directly measure the current flowing to the diode instead of measuring the voltage drop across that resistor, and by then calculating Ohm's law and
That is a good question, and actually, you should also by yourself should find that why you are not attaching an ammeter here directly and measuring the output, measuring the current, right? That is a very valid question. So, ammeter will have a internal resistance also, no? That will change. That will also add up.
yeah, ma'am.
So that will also change the
Ah,
circuit resistance, right? And that is very less.
yeah, ma'am.
So
Right.
that will disturb the circuit. Okay.
Okay,
But
sure.
in case if you attach a resistance in the series in the circuit, so there will be you can directly measure the voltage, and that voltage divided by RS is will give you the current,
Current.
actual
Okay.
current. Okay.
Right, ma'am. Right.
So, but I will also say you also read more in depth in that, because that is a very basic question, and that will also help you for better understanding in future. Okay.
Okay, ma'am, sure.
So, any more doubt anybody has?
I can see Victoria ma'am in the.
Okay. Yes.
Can
So
I
if
ask
you,
her?
yeah, sure. Go ahead.
Ma'am, am I audible? Victoria ma'am. Victoria ma'am, am I audible?
No.
Hello,
Hello?
Victoria ma'am.
Sorry, the ma'am is another meeting later. So, because, ma'am.
Okay, sir, your voice is not clear.
Hello? Am I audible?
Your voice is not that clear.
Am I audible?
Yeah, you are audible now. So I can.
Okay, ma'am, another meeting. Another
I
meeting, okay?
wanted to ask some issue related to the lab submissions. Actually, I had some components missing in my kit, and regarding this, we were told to make the payment so that the kit, the components will be delivered to us. So right now, I haven't received the delivery. And without which I cannot perform a week 3 experiments. So, sir, right now the deadline is 18th of this month. So, if I receive the delivery at the last time, suppose 2 days earlier or even beyond the deadline, so it will not be practically possible for me to submit the lab experiments. So, sir, yeah, I have received the tracking ID, but I haven't got the delivery yet. So, sir, what can be done on this? Please help.
Mail, sir. Okay.
I will mail.
Yes,
No.
um,
To whom?
any doubt you keep mailing, okay?
Uh, Sorry, sir, I didn't get you. I have to mail to whom regarding this?
So I think anybody who have any questions or doubts or any clarification from Victoria, you can always send an email to her personally, and I think she will respond to you. So I think she is not available in the meet right now. Nilesh, is it fine?
Yes, ma'am. I will mail her.
Yeah,
I've mailed
better.
also recently, but she didn't responded.
So better you can just ask, send an email reminder, a gentle reminder email. So hopefully she will respond. Okay.
Yes, ma'am. Thank you.
So if you don't have any doubts further, so I'll leave the chat, and if you don't have any doubts, you can also leave the meeting. Right?
Thank you.
Hello. Hello.
Yes. Yes.
So is it necessary to show our face in the video?
No.
Oh,
No. You have to. Sorry, sir. You have to show that yes, you are the person doing the experiment. Okay.
in every video.
Huh?
In every video.
Yeah, maybe you can show your show your card and say that okay, this is the experiment that I am doing.
I will show my. I am showing my ID card, but during the execution of the video,
No,
execution of the
no, no, no,
experiment,
no,
do
no,
I?
no, no.
That's
During the execution, how will you show your face simultaneously? Because that's when you are doing the experiment. So that is not required. But
yeah.
don't put any extra music or audio sounds behind. Okay, while doing the
Yeah.
experiment, let it be a real time video. Okay.
Okay.
Real time means real video, not to put extra or add any extra sounds. Okay, that is the only. So if you don't have any more doubts, you can leave the meeting.
Hello, ma'am.
Yes.
Ma'am, I'm having a doubt, but actually, this is not a part of that experiment. Can I ask?
Not the part of that experiments means from which?
Ma'am, again, I am having a basic doubt.
Huh. Yes.
I am having doubt that suppose, ma'am, I have taken the 12-volt battery. Huh? Hello.
Yes. Yes. I'm getting. Yes. I'm following through. If you have any doubts regarding this experiment, you can ask here. Hello.
Ma'am, hello.
Yes. If you have any
If
doubts regarding this experiment, then you can ask. Other than this experiment, I'm not like.
actually, I regarding that sine wave.
Yeah, regarding the sine wave, yes.
Ma'am, suppose I have taken the 12-volt battery, okay, and the negative terminal of the battery, is it 0 volt or it is minus 12 volt? I have confused in that.
Battery means you are not using in a battery, right? You are giving the signal from the ADLM kit, right?
No, ma'am, I have a general doubt.
No, from battery you cannot do, right? So from signal you
but
will just
apart
from that, I have not experimented with battery before, so I don't know.
okay, sure.
Any more doubts regarding this experiment?
Ma'am.
Yes.
Before 18, if you have any doubts, how can we connect to?
You have to send an email to Victoria. She will just
I mean,
send
regarding
me.
the experiment. If we have a doubt, regarding the experiment.
If you have any doubt regarding the experiment, you have to send an email to Victoria. She will inform me, and I'll answer your question through her.
Okay.
Yeah. Any more? Anything? Any question?
No.